Hello and welcome, Professor Mariana Alves Pereira, and thank you for joining us.
Thank you for having me.
Thank you. Today we're exploring a topic that often sits in the background of discussion about renewable energy. This issue of low frequency sound and infrasound, particularly as it relates to wind turbines and their impacts on surrounding communities. It's a subject that's complex, sometimes controversial, and rarely gets the serious attention it deserves. We're honoured to have you with us today, someone who has spent considerable time researching and understanding this space. Before we dive into the discussion, could you please tell us a bit about your background and qualifications and what led you to focus on infrasound and low frequency sound and its effects? Please, thank you.
Well, once again, thank you for this invitation and for having me. In 1988, I began working at the Portuguese Air Force at one of their Air Force bases, and I was the technical translator then. And so in this Air Force base, there was a medical team who was studying worker pathology. So we're talking about aeronautics, big planes, military planes, big engines. And so this team was researching the effects in workers of this type of noise, infrasound and low frequency noise. So that's how I became involved with the research team, the medical research team that was investigating this. Of course, this is within an occupational setting. So as our studies progressed, so we moved away from the aeronautical people and we began studying civilians, so aircraft pilots and flight attendants. In early 2000s, we started to get phone calls from the general public saying, oh, we know you're studying this, you have to help us. And you see, we had been only in occupational environments. We were studying the effects on workers. And we couldn't believe that people in homes would have the same level of noise that would actually affect them. But yet, we went to their homes and we measured the noise, and we gave these members of the general public the same medical tests that we were giving to the workers, and they came up positive. And so quickly we realized that it wasn't only the level of the noise that was important, it was the time over which you are exposed. So in homes, of course, you're sleeping in it. Then in 2007 came our first wind turbine case. That was 2007. We presented in Lyon, the Wind Turbine Noise Conference in Lyon, France. And that's how our involvement began, specifically with wind turbines. In the meantime, after I began working at the Portuguese Air Force, I obtained a bachelor's in physics at Stony Brook State University, or State University of New York at Stony Brook. I obtained a master's degree in biomedical engineering at the University of Drexel University in Philadelphia. And I obtained a Ph.D. in environmental sciences at the Nova University in Lisbon. So that was my academic progression, which accompanied what I was already doing in terms of research.
Thank you. So wind farms are often said to emit infrasound and low frequency sound. How do these sources compare to other everyday or industrial noise sources?
Well, we like to call them wind power plants and not wind farms. We think wind farms is a very deceitful term, and so wind power plants is the term that we use. Wind power plants, their acoustic output is in fact different than many other acoustic outputs, such as refrigerators, cars, compressors, air conditioners, mostly because the output of a wind turbine consists of trains of pulses. So whereas in a refrigerator or a car going by, or these pulses, they're not as prominent as one can see in wind turbine output. And moreover, these trains of pulses, they are most important in the infrasonic range. Now, our studies have already shown that it is precisely when these trains of pulses are present, that's when people cannot sleep. And when they are absent, people have peaceful sleep time. So the big difference with wind turbines and other machines is this output of trains of pulses, which is very disturbing for people's sleep.
Okay. One, well, a lot of people seem to be concerned, and they're raising questions that the current environmental noise regulations don't measure or account for infrasound or very low frequency sound or even modulation characteristics. Is this accurate?
Yes, it's very accurate. There's a historical reason for all of this. You have to understand, back in the late 1800s, early 1900s, factories began to exist, steam engines, noise, lots of noise. So, of course, the first thing that doctors saw among people who were exposed to noise was what? That they would lose their hearing. So, in coming into the 1920s, and we're also developing the telephone, so hearing became very important. And all of legislation is mostly based on the idea that you have to hear the sound for it to be bad for you. This is very antiquated, very old science. It's not what we know today. We know that sound that cannot be heard can also affect mammals and humans and cells. But this is not reflected in legislation. And so, no, they're not adequate at all to protect people against specifically wind turbine noise.
So, why has low frequency sound and infrasound traditionally been left out of regulatory framework, especially around rural and residential environments, considering the number of complaints from people living near wind turbines?
Well, there's a whole historic reason, as I was just saying, but if I could, acoustics is a very complex matter. So we find it easier for the audience, for people who don't know anything about acoustics, we find it easier to show pictures. Pictures make this whole subject clear as water. So if I may, I will share a slide of pictures now. Can I
Please do.
do?
Yeah.
So share. Okay. Share. Okay. So this stuff in red here on the right, which is surrounded by the big black circle, that's the only thing that legislation measures in an acoustic environment, which includes all the pink stuff. So this is an entire environment, and it's actually taken, this data is measured by our team, and it is near a wind power plant, in a home near a wind power plant. But as you can see, all the pink stuff is just completely eliminated from evaluation. So if it's adequate, of course it's not adequate. We're only when people say, oh, 30 dBAs, when they use the A, it means they're only referring to these red things. Everything that's pink is eliminated. It's not even considered. So this is why we find this very inadequate. In this other picture I'm showing you, why are they doing this? Why is this done in this fashion? Again, there's a historical reason. Why do we measure noise? We measure noise so people won't go deaf. So that hearing impairment and deafness is not a consequence of noise exposure. And again, we're talking mainly initially about occupational environments. So humans hear they hear until 20 hertz. It is supposed that they do not hear sound below 20 hertz. Some authors say 16 hertz and not 20. So as you can see, the idea being, if you can't hear it, it won't hurt you. So why measure anything below 20 if you're not hearing it? And as you can see, this is what legislation does. The premise on which legislation is based is if you can't hear it, it won't hurt you. Hence, we don't need to measure anything below 20. Now, how does this become a problem for wind turbines? I'm sorry, I didn't want to go to this slide. Here's the problem with wind turbines. The trains of pulses that I mentioned before, that you're seeing a picture of right now on your screen, those peaks represent a train of pulses as an output of wind turbines. Look at where it occurs, all below 20 hertz. It's all below 20 hertz. So this is not at all measured, as you saw in the prior picture. Anything below 20 hertz, all that pink stuff, completely eliminated. So when you now have a wind turbine with pulsed trains of pulses, it's also eliminated. If you don't hear it, it won't hurt you. This is what it has been said. So just to finish, here is an example in the same house where on the left, you do not have the presence of those peaks, and here the people slept peacefully. On the night where they had the peaks, so the wind turbines were rotating, these people in this house could not sleep at all. In fact, they were compelled to take medication. So as you can see, this is the reason why legislation, whether it's in rural or even industrial areas, it's not fit for purpose. The legislation that exists today was state of the art 100 years ago. It's time to update, and updates sometimes are difficult. Besides the technical aspects, one of the major things that needs to change is this paradigm, that people don't matter. So if that switches, if people matter more than profit, for example, monetary cash profit, we're not even talking about it, overall national profit. No, it's cash profit for very small groups of people. If the paradigm doesn't change, people have to matter. That's all there is to it. And if people matter, we're human beings. We're incredible human beings. And we can find a consensus. We can find a way where we can have wind turbines and not have people getting sick and animals and all of this. So why don't we try for that instead?
Thank you. Is there any current or emerging research that could change how we understand or manage low frequency sound or infrasound?
Well, I hate to beat my own drum, but I think the work that our team is doing and what we're doing basically is increasing the resolution, looking at what's actually there. If I may share a picture, this goes back to how all of this is easier understood through pictures. So I'm just going to share another slide, which shows how we can start measuring noise properly. This is, sorry, it takes a little time. Here we
That's
go.
okay.
So again, on the top part of the screen, you can see what I showed you before. So the environment where people were sleeping well, and the environment where people had to, they couldn't sleep, they were compelled to take medication. This is in the same house. So the two pictures below reflect the same situation, but now if you see, the resolution is enormous. What each of these images reflects a 10-minute measurement. And for each second in that 10-minute measurement, I can know at what level each frequency at 1/36th octave frequency was present at the moment. You can't do this with legislation, the way noise is legislated. In layman's terms, it's like legislated noise demands that you look at noise like through a magnifying glass. Okay, so you only see what you see through a magnifying glass. We today are using a microscope. What you see on the screen is the result of looking at the acoustic environment with the equivalent of a microscope, not a magnifying glass. And that's why we can see the peaks below 20 hertz, because we're using a microscope. We're going really into the environment to see what's actually there. So it would be nice that, this sort of characterization of the environment, scientific characterization of the environment would be made. As you saw in one of the first slides I showed, all that pink stuff is not measured. It's just excluded. It's truncated. They only measure, legislation only tells you to measure those little red bars of the picture I showed before.
Hmm.
I don't know if that answers all your questions, but
Very interesting. Um, some residents report symptoms like sleep disturbance, headaches, or persistent sense of pressure. Is it scientific possible that infrasound or low frequency sound contributes to these effects, even if at times it's not audible to the ear?
oh, absolutely. Um, you see, noise or sound is, it's a mechanical wave. It's a mechanical pressure wave that's traveling along the air or propagating along the air, and it hits your body. Now, in our previous studies since the 80s, but not only our studies, other teams, namely in China and Russia, have been studying this intensively. There are actual structural changes of the cells to withstand this mechanical onslaught of the acoustic aggressor. We see this in the animals in laboratory. We see it then in the humans occupationally exposed. Some of these people who are residentially exposed to infrasound, some of them have gone through us and have had the appropriate medical tests done to them. But at large, the medical community is unaware and unfamiliar with this type of agent of disease. So they won't give you the tests that can prove that what you're feeling is because of noise. Um, yes, there is absolutely. The World Health Organization classifies noise exposure as external mechanical aggressions, yes, they can. And we all know this, right? I mean, how is it possible that that opera singer, right, can, with the voice, right, crack the crystal? How does that happen, right? So if you think about it, this is what's happening to your body at different frequencies, and we're not cracking, but yes. So yes, the answer is absolutely yes, even
Well,
if you don't know it.
that
So
brings me to my next question, because in Australia we have the term nocebo effect, and it's often used to explain away health symptoms reported by people living near wind turbines. Do you believe this is a fair assessment, or does it risk ignoring the genuine environmental impacts?
well, the nocebo effect, I take issue with the nocebo effect. Um, it is supposed to be representative of the medical conditions that occur in your body because of your mind, right? Because you're thinking about it, or you can't let it go. It's all in your brain. That's what the technical term is, a psychosomatic. So when you have a psychosomatic disease, in theory, there is no organic basis for it, you see. So first of all, in terms of medical sciences, you cannot say that something is or is not a nocebo effect without a medical test. So even if people want to claim that what people are feeling under wind turbines is a nocebo effect, according to evidence-based medicine, you have to provide medical tests proving it's a nocebo effect. Otherwise, it's just talk. And again, if it's a nocebo effect, then if it's all in the human brain, oh, because I'm not getting money from the wind turbines, oh, because it looks so ugly, oh, because I'm so annoyed of them, right? That's how you get sick. This is what they're claiming. Well, then one wouldn't expect to see any health issues in animals then, right? If it's all a psychosomatic origin. So I'm just going to read out very quickly the sorts of problems that animals have had when living near wind turbines. So in France, the cows registered a dramatic fall in milk output. In Korea, the cows are reported to have many cases of fetal death. In Poland, the stress parameters and productivity of exposed geese had a negative effect. In England, the badgers had higher cortisol levels. In Poland, the pigs, the meat quality decreased significantly. In Spain, a rabbit farm had to close down because of the death of animals, as the mink farm in Denmark that had to close down because of the death of animals. And in Japan, the frogs are showing bad effects due to the exposure to wind turbines. So nocebo effect, look, you'll have to come up with something else because it's unsustainable. Scientifically, this concept is unsustainable for wind turbine symptoms, for people who develop symptoms under wind turbines.
Okay. Do you believe that future noise regulations will evolve to include infrasound and low frequency sound? What scientific or political barriers would need to shift in order for regulations to reflect the full range of environmental noise and to ensure that real meaningful data is being collected?
Well, that question has many tiers, but look, I think it all boils down to the shift in paradigm, you see, because even if the science is there like it is today, if there is no political will to apply the science to legislation and to our human communities, it has to start with political will. And until the political will puts people before profit, this isn't going to happen, right? Because the hidden cost of sick people and sick animals doesn't factor into the perceived economic benefits of wind power plants. And that's a level that's outside the scientists' level. I mean, scientists can provide evidence to promote that change, but scientists are not in charge of that change. So again, it really has to come from the top down, the paradigm change to put people first, and at least people first. That's what has to change.
Thank you so much for sharing your expertise today. It's clear that it's a complex and evolving issue, and your insights help deepen our understanding of what's at stake. Thanks dearly. Sorry, thanks dearly. There seems to be a real gap between what regulations currently measure and what is actually present in the environment, and the potential impacts that may be having on people and communities. And I really thank you for your time today. It's greatly appreciated. And I really appreciate the clarity with the way you present. Thank you very much.
Thank you for having me, Teresa. Thank you.